headsets or smart glasses or even wristband. There's a constant need for miniaturization at the system level to really make a better use of the 3D space with a flexible form factor and thin, but also from a customization point of view. You can truly design and only include the features that you really need to avoid wasting unnecessary space for the system.
The smart window we are demonstrating here work in the same principle as an LCD display. It's possible by applying an electric field that you can control the light transmission of that window from basically transparent to completely black, and this switching takes place in the millisecond range. That's a great example that can be used in buildings for energy conservation.
We do wearables, we do glucose meters. If you can think of an application, we can do a display for it. Part of the beauty of the displays is they're really thin, they can conform, and so you can put a display where you could never put a display before.
Let's get to healthcare. For instance, predictive maintenance, assistive technologies and so on, where you can have the material into a shoe sole to monitor gait, or in a mattress for patients who are bedridden. You can also extend this to sports direction for having like information from a racket, how it's being handled, or in a football, for instance, where the ball is being kicked with which forces. So there are endless possibilities.
LOPEC is like a class meeting where everyone comes together, so we are really happy to enjoying LOPEC.